My name's Anthony Rowen, lead engineer at Capture H2O, and today I'm going to be introducing you to the high cycle program. High cycle program utilizes a set of dual alternating high efficiency softeners installed on the makeup line to a cooling tower system to control for scale, corrosion, and bacteria in place of a traditional chemical treatment program. There's three issues we're worried about in cooling tower systems: scale, corrosion, and bacteria. And I'm going to talk you through step by step how we address each of those problems with the softener system. The first one being scale. When we install our softeners on the makeup line to the cooling tower, we redirect 100% of the makeup water through our pretreatment system, removing 100% of the scaling ions, magnesium and calcium, which are the building blocks for scale. When you remove these scaling minerals from the water, we can begin to increase cycles in the cooling tower without risking scaling tendencies in the tower itself. Which leads us to step two, corrosion control. When we begin increasing our mineral concentration and our cycles in the cooling tower water, our pH will also rise naturally. When we reach a pH above 9 and our silica, which is one of the many dissolved solids in water, reaches a concentration above 200 parts per million, that will cause the silica ions to convert from monomers, these free-floating ions in the water, to a polymer, merging together and creating a single ion-thick passivation layer coating all the wetted surfaces in the system, acting as a natural corrosion inhibitor. Now, we're not coming at you with some crazy science here. Silica has been used for many decades in various systems as a corrosion control mechanism. Closed-loop systems, radiators, car batteries. It's just not often used in cooling towers because of the hardness in the water. When we pre-treat the water, remove the hardness, and can achieve a high pH and high silica environment, we're able to utilize the silica in the water to control for corrosion. Lastly, step three, bacteria. Very similar to how we control for corrosion, when we increase our pH and increase our conductivity in the cooling tower, that creates what's known as a biostatic environment. And it's an environment that bacteria cannot exist or procreate within, using two principles that have been around for thousands of years. First being high conductivity. It's what we see in the Dead Sea. High osmotic pressure impacts life forms' ability to survive. The other phenomena is high pH. It's what we see when we wash our hands with caustic soap. When we increase the pH in an environment, it kills a significant amount of bacteria. Oftentimes you'll see 99.9% of bacteria can get killed by soap. It's not 100%, much like the Dead Sea. There are life forms in the Dead Sea. There are bacteria that can exist in that high pH environment, and there is also bacteria that can exist in a high conductivity environment. However, together, a high pH and high conductivity environment, there is no bacteria on Earth that can exist in those conditions. And that's what we're creating naturally with the high cycle program. Installing water softeners on the makeup line to remove all of the hardness, which gives us the ability to increase cycles, increase pH, and increase conductivity in the cooling tower to control for corrosion and bacteria. And notice I didn't mention a single chemical in this approach. We're able to use the natural chemistry of the water to provide great control while significantly reducing the water consumption in a cooling system.
This program is so interesting because we're not using anything novel, right? We're using scientific principles that have been used for centuries to be able to solve for corrosion and bacteria by using just the natural chemistry of the water.